I'm starting off with half an hour on pythons, penguins, and whales. First, let me introduce myself. My name is Chris Frank from Hewlett-Packard. I work in what we call the EMEA Cloud Pre-Sales team, which is basically means that I travel Europe and tell everybody how cool OpenStack and open source is. It's not a hard job, but a good one. And as you probably might know, is that we are going to split ourselves up, Hewlett-Packard, into two companies. So for today, this is the last time for me where I have an all blue presentation, and we're all blue. After November 1st, we'll be Hewlett-Packard Enterprise, and our color will be turquoise. So, but for now, it's still blue. And we're still one company with the consumer. And so did I mention that we make phones again? We do, okay. Let's start. I have to apologize. I made a mistake. I was actually thinking that I had more time, so there are more slides than I can use. So I will flip through some of them. Don't worry, you get them as far as I know at the end of the show anyway. But it's not that I don't want to show them, it is because I prepared for a bit more time. My mistake. So what are we going to talk about? We stick with the overall motto of this event, the folgende step. I hope I pronounced that correctly, which I translate the following steps. So what do we do now that we have OpenStack working? And that's what I'm going through. There is two things I need to talk about up front. One is we believe in open source. Second, and I'll be quick, you can read all the text, we do not fork. So whatever we do for Cloud Foundry and OpenStack, we do not fork. So whatever you get from us, it's based on the trunk versions. Maybe enhanced, but not changed. And there is no discussion on cloud without pets and cattle. You've probably seen it today. I just wanted to come back, ground this discussion in what are we talking about here? We're talking about OpenStack, we're talking about cloud, and we're talking about things that will run on top of the cloud. But we're not talking about enterprise virtualization. And we're not talking about enterprise virtualization with a self-service portal, because that still doesn't make a cloud. Cloud has something to do with having certain types of applications that run on certain types of machines. It's called cattle, that we usually define as cattle, where you have the ability to massively scale, where you have a built-in fault tolerance in your application, and where you don't rely on things like local storage or stuff. Very much in contrast to, where we all came from, what we call the pets, where you have a machine, maybe it's your main exchange node that you very much take care for. It has its own patch policy, its own name, it has a dedicated sysadmin and a dedicated patch policy. Yes, there's still the need for it. It will always be, but that's not what we want to talk about here. What we talk about here is basically the cloud side of things, where we have scale, where we have the ability to grow and shrink as much as we want. And try to keep that in mind, because that's where OpenStack comes from. That's where we shine in the area of cattle. We really do, both OpenStack and all. As a company, we do both, but we're now here for the cattle. So what do you run on cattle, right? We are kind of at the point where we said, okay, we have figured out how OpenStack works. We know what it does, but now it actually needs to earn its keep, and it needs to do something. And what it does, it runs applications. Quick look into what traditional applications are. How do you get them? Yeah, you write the code, you put them through a process, you configure your infrastructure, da-di-da-di, it always takes a long time. And yeah, roughly we talk in weeks, maybe months, in release cycles of 6 months, where you actually go out, build the application, you resolve all your runtime issues, you put in the libraries, you apply patch policies, that you run it, you test it, and then you push it out. And then it starts all over again. That's a fairly complex process. It can be automated. That would be in what's commonly referred to as DevOps, where you can actually take all your development and link development and operations together by allowing a single chain of tools along all the way. Again, that's not where we want to go today. We could probably spend a whole day on DevOps, but today we want to look at what we call the cloud-native apps. Cloud-native app means basically the developer writes the code in Python, for example, or in Ruby or Node.js or .NET or whatever, and then pushes it out to the runtime that is sitting on top of the cloud. That then takes care of resolving dependencies, adding databases, you name it, putting in message queues, and also takes care of high availability and scalability. So that's the idea, that if we write cloud-native apps, the whole middle thing where we actually have to go out and download a kernel, put in kernel-specific libraries, patch, look at dependencies, look for libraries, and whatnot, vanishes. But instead, we give the whole control to the developer, to let them develop the code, push it to the cloud, and have the cloud then take care of actually running the stuff. I'm not saying, and by no means what I'm saying is that we don't need sysadmins anymore. We need them very much, still to keep the whole beast alive. But the idea is that we don't need sysadmins to provision the resources for an application anymore. So the key thing and the key person here in this whole should be highlight the word developer. Is the developer, right? So as far as, I come from sysadmin background, so learning the mindset of a developer and starting to think about how do developers live and all the tools they use, stand-up meetings, Kanban sheets, and whatnot, took some time, but it's definitely worth learning, and second, if you want to run a cloud-native environment, you will have to. With going to cloud-native, the key thing is we don't talk about sizing and flexing. We talk about scaling. What does that mean? If we look at traditional enterprise virtualization, you had functions like, okay, I need to add a vCPU here and some more virtual memory here. That's not what we're talking about when we want to look into scaling. Scaling is, I run 500 web front ends because there is a good show when I do streaming TV, I've run 500 web shows, and there is a new series coming on, and I need to deploy 500 more to cope with the demand. And then during advertisement breaks, I just can scale down to 200. The show starts again, I scale up to 1,000. That's what we talk about in scale, and that's what this whole thing is about. It's about scalability. And it means certain things for your application. And one is, it has to be stateless. There's no way that you can get state from a local file system if you have to deploy 600 new VMs in in rather short times. That doesn't work. So it has to, the whole thing of cloud native is in the application. And again, developers first. So what we build from here and will be targeted at developers. And we enlisted very prominent help here. Okay, never mind. That was picture the famous image of Obama teaching a schoolgirl. That's there. And basically that's the most important thing to understand. If we talk about native apps, if we talk about clouds, you need to be able to code. Right? And so that's now comes to our vision for the next century. Okay, maybe not for a century, maybe for a year. We want a developer-led, open-sourced, distributed, and with lots of data, preferably on our storage, and hybrid clouds, preferably from us. Okay, no, I didn't say that. Developer-led, open-source based, and a lot of data. That's what we expect in the near and the next future. So, not the next future, in the next coming years. How do we call this? We call this the application-centric cloud. We've covered OpenStack. We're done with infrastructure as a service. And I'm actually very quick here now. The next level up on infrastructure as a service is the platform as a service, which actually gives you the ability to do what I described earlier, to have your developers post the code without sysadmins into production. Companies like Facebook, they update their main web interface several times per day, right? Not in 6 months cycles. The main interface that we all use and love is updated several times per day. Right? And that's where we kind of aim at. To get there, as HP, we have decided to join Cloud Foundry, the Cloud Foundry Foundation, which is an open source like OpenStack, an open source platform as a service that we kind of where we joined the foundation that we are adopting, like we're adopting OpenStack, and then gets a new name within the HP family of tools. The last thing, the service catalog, the front end, I'm not going to cover here. That will be the level above the pass that actually gives you the choices to deploy applications, select applications like from a shopping cart. We have a solution for that, cloud service automation, but that's not for today. And for the remainder of the, probably have another 15 minutes, if I talk quickly, we'll focus on Cloud Foundry. So we call Cloud Foundry the HP Helion development platform. Basically, it is based on Trunk Cloud Foundry. It's based on the version of Cloud Foundry that that was written. I can kind of say is wrong. It's based on the Staccato flavor of Cloud Foundry. Staccato used to be part of ActiveStack, but we have announced that we are going to acquire them at one point in time. It runs on top of OpenStack. So this version of Cloud Foundry, and by no means it doesn't mean that Cloud Foundry only runs on OpenStack. Our version of Cloud Foundry, the HP Helion development platform, runs on top of our OpenStack. Why is that so? I'll show you in a minute, but basically we add in the interaction between Cloud Foundry and OpenStack, we added functionality. So that means that our version of Cloud Foundry runs on our version of OpenStack. oh, isn't that dangerous for your application? No, actually not. Because your application, you write to the Cloud Foundry API. And that does not change. So you can take the application that you write on Helium DevBlood and take it and put it to a native Cloud Foundry or a Cloud Foundry on Azure. The upper layer is unchanged. So you can port your application between various instances of Cloud Foundry. But you cannot take a pivotal Cloud Foundry, for example, and run it on top of HP Helium OpenStack. That won't work. Right? So once we go into the pass layer, the pass kind of becomes the pass API becomes our frame of reference where portability looks like. Again, there's no lock-in. You can take your, well, that was quick. There's no lock-in at all. I used the last 5 minutes we're part of the Cloud Foundry. I said, basically, how does that work? How do you actually resolve? I mean, everybody who has ever written a piece of code knows that you have to resolve library dependencies. So and that's where Cloud Foundry comes in. Basically, you write the cloud native application, you create a manifest that says, okay, I need Python 2.7 and I need MS SQL and I need, okay, I need this, I need Python, I need MS SQL. You take the application together with the manifest and send it off to the platform as a service. The platform as a service will then look at it and says like, oh, Python, so I need to put in a Python build pack. It's kind of an encapsulated Python, libraries. It looks at it and says, oh, I need a SQL database. I fire up a SQL database from a catalog of services, and then throws it out to a runtime that can deal with these build packs. In HP Development Platform, the combination of the cloud native applications plus the build packs we put in Docker format. And then, as part of the runtime, we have droplet execution engines that execute these Docker images and take care of their health, take care of high availability, if you specify that. With the next version of Helium DevBlood 1.3, we can actually run native Docker applications, meaning that we can take Docker images that you have created outside of Cloud Foundry and run them on the Cloud Foundry runtime. Yes, the cloud. Yeah, I mentioned we use Docker containers. That's not all Cloud Foundry implementations do that. We have admin interfaces. We integrated the cluster generation into Horizon so that you have a very nice and very tight OpenStack integration. The last minute I want to spend on two things. We've heard the OpenStack Summit, Tokyo. If you have the chance, go there. But we're not talking about OpenStack only. We're talking about Cloud Foundry, and there is a Cloud Foundry Summit too. The Cloud Foundry Summit is November 2 to 3, 2nd and 3rd, in Berlin. Registration is, I think, almost free. Plenty of spaces. We'll be there, probably everybody else who was involved in Cloud Foundry too. Definitely worth coming. It's a Monday, Tuesday in Berlin. In time? I'm in time. Okay. Par force, tour de force, going through from cloud to Cloud Foundry. I will be at the booth at the end. I can tell you whatever you want to know about technical details, how we do what, how you can start with it. It is downloadable, and thank you for your attention, and I hand over to the next person.